Tamil Core channel சார்பாக அனைவருக்கும் வணக்கம். என் பெயர் கண்ணதாசன். Today we are going to discuss about DNA part 3. Features of DNA. First feature, if one strand runs in 5' to 3' direction, the other runs in 3' to 5' direction in order to establish the antiparallel nature of the DNA. But yesterday I told you, whenever we say the direction, it should be from 5' to 3' only for both the strands, because the 5' end as phosphate group and 3' end as OH group. Okay, that is the reason why it established the polarity. So we can say both the strands run from 5' to 3', but in the opposite direction. But in CBSE as well as StateBoard book, it is given as one runs from 5' to 3' and 3' to 5' another strand. So you can follow the same, but you should notice one picture given in the StateBoard book. Here it is given as both the strand 5' to 3', 5' to 3' only, but in opposite direction. So it is your choice to follow which pattern you want to follow. Next, third character is the angle at which the two sugar protrude from the base pair is 120 degree for the narrow angle and 240 degree for the wide angle. This is about the minor groove. Okay, its angle is 120 degree and major angle, its angle is 240 degree. So put together you will get a 360 degree of a circle. Okay, so next one is, and here if the DNA is having a normal symmetrical regular helical staircase like structure, then the grooves are equal in size. But in DNA, two grooves of unequal size are created because the bases are asymmetrically attached to the sugar phosphate backbone. Okay, asymmetrical attachment of the sugar phosphate backbone. That is the reason why we get one side minor groove and the other side major groove. You see major and minor in the bDNA. Okay, next one is, before we are going to learn about the size of the DNA. Okay, these are all the measurement I gave you to understand the size of the Armstrong and nanometer. 1 Armstrong unit is equal to 10 power minus 10 meter. 10 power minus 10 meter. 1 nanometer is equal to 10 power minus 9 meter. 1 Armstrong is equal to 10 power minus 10 meter. Okay, so DNA measured in terms of either nanometer or in terms of Armstrong unit. Each base is about 0.34 nanometer apart. A complete turn of helix comprises 10 base pairs, so 0.34 into 10, 3.4 nanometer. In terms of Armstrong unit, it is 34 Armstrong unit, and the width of DNA is 20 Armstrong unit. Okay, with respect to this CBSE book, one in-text question asked. Okay, that question is, why the distance between the two polynucleotide chain in DNA remains almost constant? The reason is that purine bases link with pyrimidines, but not within the purines or pyrimidines. See, one purine, you see, thymine is a pyrimidine. You join with the purine adenine. In the same way, guanine, purine, it joins with the pyrimidine cytosine. Okay, if it joins adenine versus guanine, thymine versus cytosine, definitely the width of the DNA will not be the same all along the length. Okay, because here one purine, one pyrimidine joins, and here one pyrimidine, one purine joins, and moreover the bond between these purine and pyrimidine hydrogen bonds are with equal length. That is also one of the reason for having the same width for all along the length of the DNA. Here you see there are 10 base pairs to complete one turn for 360 degree. One turn means one complete turn 360 degree. Then each nucleotide deviate from the previous nucleotide for about 36 degree. That point also to be noted. Approximately each nucleotide deviate 36 degree from its previous nucleotide. Then thermodynamic stability of the helix and specificity of base pairing. How the thermodynamic stability, okay, while heating also the temperature increase also DNA is not easily destabilized. This is because of the presence of hydrogen bonds and also stacking interaction between the bases tend to stack about each other perpendicular to the direction of the helical axis. Then the stability continues. And one more point, electron cloud interaction between the bases. That is also one of the reasons why the stability of DNA is maintained, and also phosphodiester linkages and strong, almost all the bonds in DNA are strong covalent bonds only. That is also one of the reasons to maintain the stability. Then plectonemic and paranemic coiling. Plectonemic coiling means, okay, it is very difficult, you see, making it impossible to simply move them. It means DNA strands away from each other without breaking the entire structure. You have to break the entire structure in order to separate them. Then the coiling is said to be plectonemic coiling. So it is a very tight coiling. If it is very loose coiling, making them easier to pull apart, then it is called as paranemic coiling. Then forms of DNA. Three forms of DNA discussed in our book. Okay, bDNA, aDNA, zDNA. In addition to that, eDNA, ddNA, cDNA also present. First, bDNA. This is the most common type. Right-handed pattern. The helix form on the right-hand side. Okay, and the core consists of nucleotide bases. Peripheral region consists of sugar phosphate bond. And A form. Actually, A form is it can be formed from the B form. Okay, by chemical treatment. Here you see. Okay, the normal physiological condition like 75% of relative humidity and the presence of sodium, potassium, cesium. Okay, at that time the DNA is in the A form, and this is the second most common form. This is also having right helical structure. Next, zDNA. Z stand for zigzag. zDNA is a form of DNA that has a different structure from the more common B form. But here it is left-handed double helix, zigzag pattern. zDNA only a minor groove. It consists of only a minor groove. Major groove is absent. Okay, so these are the right-handed pattern. From the picture you can see right-handed pattern. This is the zDNA left-hand pattern of helix. And here the features of bDNA, aDNA, zDNA are given. Okay, highlightingly this type of helix, right-handed bDNA, right-handed, left-handed, and the helical diameter also given, rise per base pair, then distance per complete turn, 3.4 nanometer, 3.2, 3.4, 3.2, 4.5. Topology of major groove, you see here it is wide and deep, narrow, deep, flat. Topology of minor groove, narrow, shallow, broad, shallow, narrow, deep. So this is the comparison of the three DNAs. Then in addition to that, aDNA, eDNA, E because of cytosine methylation or bromination of DNA sequence GG, CG, CC. So extended DNA is obtained. That's the reason why it is called as eDNA with deep major groove and shallow minor groove. It is formed as an intermediate between bDNA and aDNA. Next, cDNA. Okay, at 66 degree relative humidity, in the presence of lithium and magnesium, it is formed right-handed 9.33 base pairs, diameter 19 Armstrong unit. ddNA. Extremely rare variant with only 8 base pairs per helical turn. These forms of DNA found in some DNA molecule which devoid of guanine. So from up to this part 1, part 2, part 3, you would have completely understood about the DNA. Thank you for watching part 3. If you like this video, press the like button, share this video to your friends, comment on it, subscribe our channel and press the bell icon to receive more such videos in future. Thank you, students. Thank you.